Now I've been talking about the different shapes of the distribution as left skewed or right skewed. So let me just summarize this. So left skewed means that you have a left tail. So you have a few extreme values that are low to the left. Right skewed means you have a right tail, so a few extreme values that are high to the right. And of course symmetric means just what it sounds like, you have a nice symmetric distribution. There's a special type of symmetric distribution called a bell curve or a normal distribution that we're going to talk about a lot in this course. So I'm just going to introduce it now just to get you thinking about it. So a bell curve is just what it sounds like. It follows the shape of a bell. It turns out to be very important in statistics for a number of reasons. So I'll just say a little bit more about it now. So the reason it's important is, for one thing, it has sort of a predictable behavior that makes it very useful. So it turns out that if you're on a perfect normal curve, that 68% of your observations will fall somewhere between 1 standard deviation below the mean to 1 standard deviation above the mean. 95% of your observations will fall within 2 standard deviations of the mean, and 99.7% will fall within 3 standard deviations of the mean. And if you don't know what a standard deviation is, don't worry, we're going to talk about that in an upcoming module this week. But it has nice predictable behavior, so that's very useful for calculating statistics. Another reason the normal distribution comes up a lot is that many traits that we might measure in a population follow a normal distribution. There's lots of traits that don't follow a normal distribution, but there's a number that actually follow a normal distribution. So things like IQ and height tend to fall on a bell curve. So that's another reason it comes up a lot. Finally, the most important reason that the normal distribution is so important in statistics is actually that statistics themselves tend to follow a normal distribution. And this is a bit of a tricky concept, but it's something I want to plant in your head now because we're going to be talking about this in great detail in a couple of weeks. So it turns out that statistics, things we measure from our data like means and odds ratios and regression coefficients, those also have a distribution. And it's a tricky concept because if you think, like I do a study, I measure one mean in my sample, how does a single mean have a distribution? Well, it's something that's a theoretical construct. But it turns out that that distribution is often a normal distribution, and that's really the reason that the normal distribution is so important in statistics. So I'm going to end here with just showing you some histograms of the data from my Stanford students. I think it's always fun to look at histograms of real data. So for example, I asked my students to rate their optimism on a scale from 0 to 100. And you can see that, most of my students are feeling pretty optimistic when they took this survey, but I did have a handful out to the left. We would describe this as having a bit of a left skew. There were some students who were more on the pessimistic range. I asked them about their daily fruit and vegetable consumption in servings per day, and you're supposed to eat 5 servings of fruits and vegetables per day. Not everybody was meeting that, but in general, my students are pretty healthy. They were doing a pretty good job. I even have students eating 6, 8, 10 fruits and vegetables a day. Interestingly, this distribution would have been a nice normal curve, except that we're missing the left tail, right? There wasn't anybody who was eating no fruits and vegetables every day, which is a good thing. And so we're missing a little bit of a left tail there. If we'd had some people eating none, this would have made more of a bell curve. Here's another interesting variable. I asked them how much homework they did in hours per week, and you can see that there was a wide, I got a wide set of answers here. So for those of you who are out there who are full-time students, you'll be very interested in how much homework my students were doing. To be fair, I asked some of the students this question at the very beginning of the year, so maybe some of them didn't have any homework yet, but that the homework might have been coming later. But I had a lot of students reporting 0 to 5 hours of homework per week, but then I have a really big right skew, a big right tail here, with some students reporting as many as 40 hours per week of homework. I asked my students about alcohol drinking. How many alcoholic drinks do you drink per week? My students are fairly light drinkers, as you can see. I don't tend to teach undergraduates. I mostly teach graduate students and medical students and doctors, and they were fairly light drinkers. The heaviest drinking I had reported here was 7 or 8 drinks per week, and most people are drinking just 0 to 3 drinks per week. Finally, a question I always like to ask my students is how they feel about math. And I asked them to rate their feelings about math on a scale of 0 to 100, with 0 being really horrible feelings about math, and 100 being they love math and go home every day and do math just for fun. And so you can see there is a wide range of feelings about math in my students, a lot of the students tend to be favorable, but I definitely have some people in the unfavorable range. And interestingly enough, this variable of all the ones that I've shown you so far turns out to be the closest to a normal distribution. It's certainly not a perfect normal distribution, a perfect normal curve, but it's actually the closest of the variables that I've shown you so far.